Namaste, welcome to Pythagoras Academy. In this video, we'll talk about the relationship between the velocity and the speed, the physical quantity velocity and speed. So velocity is a vector, whereas speed is a scalar. Velocity has got both magnitude as well as the direction. Speed has got only the magnitude, and the definition of speed is rate of change of distance with respect to time. The definition of velocity is rate of change of displacement vector with respect to time. So v bar, velocity, is dr bar by dt, whereas speed, simply v, that is ds by dt, rate of change of distance with respect to time. Now I am trying to establish a mathematical relation between velocity vector and speed scalar. Consider any particle moving between 2 points. So basically, when I say velocity, it is instantaneous velocity. When we talk about speed, it is instantaneous speed. Say at this particular point of time, if I am interested to calculate the velocity or speed, so what do? It's like taking the snapshot. So at this point C, take a point C. Here at this point, if I am interested to find out the instantaneous velocity or speed, what I do is I take a snapshot. Let me say delta t amount of time is elapsed while I take the snapshot. While I take the snapshot, the particle is already here, covering a distance of delta s and displacement of delta r bar. Or it's like this. To be more clear, let me zoom this part. It's like this. So there is distance delta s and displacement of delta r bar in that very small interval of time delta t. So instantaneously, so if you talk about the average speed and average velocity in that small interval of time delta t, average speed is delta s by delta t. Average velocity is delta r bar by delta t. If you talk about the magnitude of average velocity, it is modulus of delta r bar by delta t. Is delta s equal to delta r bar's magnitude? No, it is not. Delta s is slightly higher than magnitude of delta r bar. They're not equal. But when limit delta t tends to 0, when you apply limit on these two terms, so when limit delta t tends to 0, delta s by delta t, it becomes instantaneous speed, or this is ds by dt. So this becomes ds by dt. And what about this? This becomes dr bar by dt, and if you talk about magnitude, it is this. It means when delta t is tending to 0, this delta s becomes very, very small. It becomes ds, infinitesimally small. The ds is like a small dot. So when you take a very, very small portion of a curve, it is like a straight line. Very small part of a curve is a straight line. Similarly, very small part of this delta s, that is ds. So it is very, very small, so that I can say ds is equal to modulus of dr bar, because very small part of the curve. So delta s is curve, delta r bar is straight line, but ds is small part of the curve which is straight line, dr bar is also a straight line. So the ds is equal to modulus of dr bar, but delta s is not equal to modulus of delta r bar. So what can I say about the relationship between instantaneous velocities, magnitude and speed? So they are equal, because ds is equal to mod dr bar. So I will say that magnitude of velocity is equal to speed. This is the relationship that we have established. So modulus of v bar is equal to v. This is the understanding. What about the averages? What is average speed? Average speed is total distance by total time, whereas this is like this, the entire distance, this is the distance, whereas average velocity is total displacement by total time, and this magnitude of displacement is always less than or equal to distance. Magnitude of displacement can never be greater than distance. It is less than or equal to. Under what condition the magnitude of displacement is equal to distance? If the particle moves in a straight line. If the particle is moving in a straight line, its distance or displacement both are same. So magnitude of displacement is less than or equal to distance. If you divide by time on both sides, so it would be this, which is nothing but magnitude of average velocity is less than or equal to this total distance by total time, which is average speed. This is the relation between the averages. Magnitude of average velocity is not equal to average speed. Magnitude of average velocity is always less than or equal to average speed. It can be equal, it may be equal when if the particle moves in a straight line. Only under the condition that the particle is moving in a straight line, its average velocity's magnitude and average speed are equal. Otherwise, average velocity's magnitude is less than average speed. But under any condition, be it any path, straight line, curvy, parabolic, any path, magnitude of velocity is equal to speed. So what is the derivation that we can make out of it? Velocity is nothing but speed plus direction, because the magnitude of velocity is speed and it has got certain direction. So this is the relationship between instantaneous velocity and instantaneous speed. Hope you liked it. If you have any questions, you can always mention in the comments. I'll definitely try to address. Thank you so much.